But today we're taking our next step with G1. And a big part of this, as I'll come back to, is kind of highlighting that this is not a one and done kind of thing. This is a new technology foundation, and it's a foundation that from here we'll build on, and we'll continue to build. We have that really nice distributed massive MIMO system doing all those fancy things. Where can we take it from here? We're just about to share that with you. So G1 operates on 2 independent 40 megahertz carriers today. And so it's, which is really handy, by the way. Many systems operate on a single 80 megahertz chunk of spectrum, and that's more difficult because it doesn't give you the flexibility to move the spectrum around in either an unlicensed or in a licensed band. So this is a quite nice feature of G1. It's the way the system was designed from the start. With that, we get about 800 megabits per second uplink and downlink combined. So we can do really in an ideal situation around 640, 160 kind of service to customers. One of the really cool things about the design, again, I could speak for a lot longer, and actually Dale, Sergio, and some of the guys who could speak for way longer than I can about how this actually works. But one of the most amazing things about the design that comes out of that distributed massive MIMO technology is it's symmetric. What does that mean, symmetric? It means that in most wireless systems, if you want to have more uplink, it's less efficient in the uplink, so you have to give up more spectrum to serve the uplink. So if you give up 100 megabits per second in downlink, and in spectrum, you might only get 50 megabits per second in the uplink. So it's not symmetric in terms of link budget. Why is this important? Because in some places, people want a symmetric service. Certain businesses want 100 by 100, or they want 200 by 200. And this technology can deliver that. So that symmetric link budget is really huge. It lets us do some things that wireless systems heretofore just weren't able to pull off. And it's a very unique thing. So G1x2, you guessed it, it's 4 carriers of 40 megahertz. 4 independent carriers of 40 megahertz. Sorry, a total of 160 megahertz of spectrum. Now, for those of you that are familiar with wireless systems, you know this is not easy. It's not like you can snap a finger and add 2 carriers. This is hard stuff. There's physical layers involved. There's quite a bit of technology all the way through the system, all the way through the MAC layer, through everything we do, all the pieces of technology to do this. But G1 actually has the capability to do this. And what this is going to give us is gigabit. So NGFWA is now going to be able to offer gigabit service. Now let me say a few words on gigabit because I think it's important. It's of course, a lot of people say, oh, I want gigabit. And the truth is that, our view, most customers that get a couple hundred megabits per second, 200, 300, even 100 truthfully, but you get into 200, 300 range, you're going to be pretty happy. A 4K TV might consume at when you're running it, let's say 15 to 20 megabits per second. So if you have a couple of those running and you're doing some gaming and you're doing and, it's pretty hard to get your demand up into the hundreds of megabits per second. So if you have a service like, you're going to be very happy. By the way, you're going to pay more attention generally at that point to latency than you are to burst bandwidth. And the reason for that is when you are web surfing, latency is what makes it feel snappy. And a lack of latency not only impedes voice over IP and it impedes video, it makes it laggy, it also makes web browsing a little less quick because there's a ton of transactions that happen every time you're clicking a web page. And if there's latency, that adds up and it starts to feel, even if you could have a gigabit service and it could feel actually sluggish. So the point is that when our customers deliver hundreds of megabits per second, let's say a 200 meg, 100 meg, 200 meg, 400 meg service, customers are going to be pretty happy. And chances are, they're going to stay with that service as long as they're getting good customer service. On the other hand, if you're coming into a new community and you're getting flyers, gigabit ends up being a pretty interesting thing to be able to offer. Some of our customers have asked us that they would really want to offer a gigabit tier. And to do that, G1x2 is going to let that happen. Now, you might say, well, G1x2, geez, man, that's a hard technology. I'm guessing that's going to be in 2026 or something like that, right? Wrong. Actually, the new system will also add 6 gigahertz spectrum, and it's going to be available in mid-2023. And what this is going to allow us to do is going to allow us to basically not only do 4 carriers of 40 megahertz delivering 1.6 gigabits per second, double the previous. I said 800 before. Now we have a 1.6 gig to allocate to uplink and downlink. But it's also going to let us exploit the new 6 gigahertz spectrum, which is a huge swath of spectrum that's unlicensed, but is relatively unpopulated. So and with our interference cancellation technology, we're going to be able to go into that nice piece of spectrum. And we can even have some in 5 and some in 6, so we can kind of flexibly decide where to put those 4 carriers. Again, this is very unique. Most systems don't have 4 carriers of 40. The Wi-Fi systems are generally one big carrier of 160, which is a real problem. So it gives you a lot of flexibility where to place your spectrum. We're going to deliver a new 5-6 gigahertz remote node and base node. And as I said, this is all going to be available in mid-2023. This is already very far into design. But actually, there's more. We're actually going to also be able to offer gigabit service on our current system. Now, this might surprise you a little bit, because you say, well, that new system must have a whole bunch of new hardware in it. And the answer is, well, actually, the current system we're shipping today will get a software upgrade that's going to allow it to offer gig tier services. This is pretty unheard of. And I'll call up Sergio Nadevsky, who is one of our founders, and I call him our chief everything officer, because he's played every role in the company since the beginning, 27 years ago. OK, actually, it was more like 13 or 14 years ago. Sergio, yes. Welcome.
Thank you, Basil.
So Sergio has been deep into the design and development of G1 from the very start and the products that were previous to that. And it's going to walk you through a little bit how this system will perform in terms of range. And maybe a little bit, maybe you could share also, Sergio, a little bit about how did we pull this off? How is it possible to take a system that's delivering 800, right? And then all of a sudden it's delivering 1.6 gigabit. Doesn't seem reasonable.
That's right, that's right. So thank you, Basil. Maybe I'm going to start with that. The reason why we can do this, and this is indeed not reasonable for other systems, is because, as you guys know, we've built this entire system from scratch. The baseband was built from scratch, the hardware architecture, the physical layer, the MAC layer, and we've put a lot of processing power in our chipset. We planned a number of steps ahead to make sure that the chipset is designed to deliver gigabits per second. And the fact is, because we have all of the system under our control, the protocol, the chipset, and so on, and we have a lot of horsepower, we can actually reconfigure the system to deliver according to customer demand and market demand. If the market demands a gigabit, then that's something that we can actually deliver with our system. And that's what we've done. So a little bit about the range for X2. And I'm first going to start by reiterating just how awesome our existing G1 is. So on the left-hand side, we can look at the performance and the range of our G1 existing product in line of sight in CBRS, the top left corner, and 5 gigahertz. And as you can see in CBRS, we can actually go up to 20 miles, limited really by the curvature of the Earth, and offer 500 megabits a second, which is really amazing.
I think it's cool when you can say your product is limited only by the curvature of the Earth. Which means, by the way, which means you don't subscribe to the flat Earth thing.
I do not. That's right.
Be clear.
I have to be clear about that. Yes, yes. The Earth is round. So, you know, more than 1,000 square miles. I mean, that's a huge area in which you can offer that. In 5 gigahertz, of course, the range is more limited. But even there, you can offer 200 megs at the same 20-mile radius and about 7.5 miles for 500 meg service, which is still very, very good. Now, the middle panels there represent what we can do in very, very hard no line of sight conditions. And you know, when we mention that, we're really thinking about urban, dense no line of sight with multiple buildings that are obstructing our signal. And even in those environments, our system offers miles of range at very, very good speeds. Now, coming here to X2, what X2 will be able to deliver, to start with at least, is deliver gigabit speeds at about 3.7 miles in line of sight, which may look modest, relatively speaking, compared to what G1 can do at lower speeds. But the reality is that we're still talking about 43 square miles of area which is covered to gigabit service, which is quite remarkable and not something that we can do with other solutions. And we can also cover about half a square mile at this point in non-line-of-sight environments for dense urban deployments. And that, again, is plenty because those dense urban deployments are going to have high-density users, and that's going to be very valuable.
Perfect. And you mentioned the non-line of sight, of course, when you've been hearing the videos, the non-line of sight line of sight is great, but when you're looking for vertical assets, another fancy name for a cell tower or a water tower, a high percentage, especially in Litchfield or in places where there's a lot of trees, a high percentage of your installs are going to be non-line of sight. So it is really important to have both tools. Now, of course, non-line of sight is not going to go quite as far, but it's a really important part of the story. So speaking about gigabit for a second, we're going to extend that range over time. Isn't that right, Sergio?
That's just as you mentioned, Basil. We have a lot of different steps in our multi-year plan over here. And one of the concrete plans we do have is actually stretching this much further than it can go right now. And we're actually working on this. I'm assuming we're going to discuss this more in our next product launch over there. And we have many other components that we're working in our roadmap because we want to make sure that we're always one step ahead of the competition. So if the demand will be to increase the capacity of the network in aggregate and per sector capacity, that's something we're going to deliver.
Right.
If we're going to have demand for multi-gigabit service, we're going to deliver that as well. And what's even more important is that the strategy is to make sure that we deliver this in a, I would say, seamless upgrade model. Because we want our existing customers to be able to benefit from continuous upgrades in performance and quality, and for them to always be a step ahead of the competition and a step ahead of the consumer demands
as they come. By the way, that's really the point. I mean, I think one of the things that's clear is NG-FWA is not a point in time. It's going to continue to grow.